plus 65 is equal to 0. Find all other roots. Now, our equation is a polynomial equation of order 4, and we have one of the root. Since our equation is a polynomial equation of order 4, that means we shall have 4 roots, and we have been given one of the root. And therefore, we shall apply the root theorem, the conjugate root theorem, which says that if we have a polynomial equation and all the coefficients in that polynomial equation are real, then the complex roots occurs as conjugate pairs. So that means our equation z to the power 4 plus 2z squared plus 32z plus 65, all of the coefficients are real. We don't have an imaginary coefficient. Therefore, it means the roots to this particular equation, the complex roots to this particular equation, will occur as a conjugate pair. So we have one of the root, which is 2 minus 3j. So that means the conjugate of this root is also a root to our equation. So the conjugate of 2 minus 3j is 2 plus 3j, is also a root. Now we have to establish an equivalent quadratic expression since we have the two roots, and this expression will help us to reduce our polynomial equation of order 4 to order 2. So the quadratic expression of these two roots will be z squared minus the sum of the roots into z plus the product of the roots. So here we have z squared minus the sum of the roots, which will be 2 minus 3j plus 2 plus 3j into z plus the product of the root, which will be 2 plus 3j times 2 minus 3j. So if we expand and factor out our expression, we shall obtain z squared minus 3j plus 3j gives me 0. Then here we have 2 plus 2, which is 4z. Then if I do the product of 2 plus 3j times 2 minus 3j, I shall get a positive 13. So this is our quadratic equivalent given the two roots, 2 minus 3j, 2 plus 3j. Therefore, since we have a quadratic expression, now we need to reduce our equation, given the equation z to the power 4 plus 2z squared plus 32z plus 65. We need to reduce this equation into a quadratic equation by polynomial division. So in this particular case, now we shall have z, our equation, that is z to the power 4 plus 2z squared plus 32z plus 65. We divide by our expression that we obtain a quadratic expression, that is z squared minus 4z plus 13. Now this, we take the division of this. Now, usually when you are doing polynomial division, we normally take the first term in the dividend and the first term in the divisor. We divide, we get the quotient. The quotient of this particular division, we put it above, and then we multiply the coefficient with each term in the divisor. So we shall have, that is, the first term here is z to the power 4, divided by the first term in the divisor, z squared, which gives me z squared. So z squared as the quotient, I put it above. Then I multiply the quotient with each term in the divisor. So that means z squared times z squared, which give me z to power 4. Z squared times negative 4z, I get negative 4z cubed. Z squared times 13, I get positive 13z squared. Then I subtract z to power 4 minus z to power 4, I get 0. Now on the top part, I don't have a coefficient of z to power 3. That means my z cubed here, it is 0. So it is 0z cubed minus negative 4z cubed, which gives me positive 4z cubed. And then I have 2z squared minus 13z squared, which brings me to negative 11z squared. I bring down the coefficient with z, which is positive 32z. I proceed with the division as usual. So I shall take 4z cubed divided by z squared. I get positive 4z. So positive 4z as the quotient. I multiply again. So 4z times z squared, I get 4z cubed. 4z times negative 4z, I get negative 16z squared. 4z times 13, I get positive 52z. Doing a subtraction, 4z cubed minus 4z cubed brings it to 0. Negative 11z squared minus negative 16z squared, that brings me to 5z squared, because this positive will cause to be a positive. Then 32z minus 52z, that's bring me negative 20z. So I bring down the remaining term, which is positive 65. Again, I take the same method again. 5z squared minus z squared, I get 5. So positive 5 as the quotient. Then 5 times z squared, I get 5z squared. 5 times negative 4z, I get negative 20z. 5 times 13, I get, that is 65. So if I do subtraction, I get my equation coming to 0. Therefore, that means the two products, the divisor and the quotient, will give me the expression we had initially. So that means that z squared minus 4z plus 13, if I do multiply with the quotient we have obtained, 2z squared plus 4z plus 5, I will get my expression, the initial expression, which was a polynomial of order 4. And therefore, since the divisor we had generated from the two roots we had, therefore we need to find the two roots or the other roots from our expression we have obtained by division, that is the quotient. So by looking at the quotient we have obtained or established, that is z squared plus 4z plus 5, this is a quadratic equation which can be reduced to quadratic, which can be solved using a quadratic method or the quadratic formula. That is easy. So in this particular case, I shall have my to get the root of this particular equation using the quadratic formula. Z will be equal to minus b plus or minus the square root of b squared minus 4ac over 2a. In this particular case, my a is 1, b is 4, and c is 5. So substituting that, I should have z, the root will be negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times 1 times 5. So this gives me a negative 4 over 2a, which is 1 over 2. So this gives me negative 4 plus or minus the square root of 4 times 20 negative 4 over 2, right? So at this particular case, I'm having my expression, which is negative 4 plus or minus the square root of negative 4 over 2. Now the equation has a negative inside the square root, so you cannot find a square root of negative 4 unless you introduce a complex term, which is j. So my expression here, because we know that the square root of negative 1 is equal to j, that is the complex. So expanding that, it means here you can have a negative 1 times 4, which is negative 4. Therefore negative 1 will be j, and therefore in the root you shall have the square root of what? 4j. So this becomes negative 4 plus or minus the square root of 4j over 2. So this now the square root of 2, the square root of 4, which is 2. So it becomes a negative 4 plus or minus 2j over 2. Now we have already the two roots, that is negative 4 plus 2j over 2. Another root will be negative 4 minus 2j over 2. So since it is over the same common denominator, that is 2, the same denominator can divide each term in the numerator. Then we shall have, we obtain negative 2 plus j, or negative 2 minus j. So these are the other two roots we have obtained from our expression, which was the quadrant, the quotient of our equation, z squared plus 4z minus plus 5. So we have the two roots. Now again, check at this particular level. This root, negative 2 plus j, is a complex conjugate of negative 2 minus j. That means the conjugate root theorem still upholds that if we have a polynomial equation of any order and all the coefficients of that particular polynomial equation are real, then all the complex roots will occur as conjugate pairs. So that has repeated itself. So in other words, now our expressions to find the other roots, we had our first root, therefore we have established the 4 roots, which is 2 minus 3j. We have another root, which was the complex conjugate of this, 2 plus 3j. Again, you have obtained another root, which is negative 2 plus j, which is also its complex conjugate is negative 2 minus j. So these are all the roots to our equation z to the power 4 plus, what was our equation? Z to the power 4 plus 2z squared plus 32z plus 65 is equal to 0. So the roots to this particular equation are the ones that we have established. So thank you very much. Enjoy your revision. If you have a question, again, you can post, you can share, you can subscribe to this channel for more. Thank you.